Hello guys, welcome back for another question from the chapter integration, or we can say integral functions. And let us see what does our question say. We have to find the integration of the function 10x raised to the power 4, and we have to integrate it with respect to x. So how do we solve this question? The idea is to break this function into a simpler trigonometric functions, or the combination of different trigonometric function separated by plus or minus whose power is 1. So that is our motive. And this trigonometric function t1 or t2, or it can be plus minus t3 or plus minus t4, as many as you want. And these can be anything: sin x, 2x, 3x, anything, 1, 0, anything which you can think of. The only condition that should be satisfied is these terms should be separated by plus and minus, and they should be trigonometric terms or the constant. So let us see how do we approach this question. What should be our first step? So 10x raised to the power 4 can be written as sec square x minus 1 into tan square x. How do we get this step? Let me show you. I'm erasing the redundant part which I wrote just now. Okay. We already know that tan square x, we already know that tan square x is equal to sec square x minus 1. This is our identity. So we are breaking 10 raised to the power 10x raised to the power 4 as tan square x into tan square x. And we replace tan square x, one of the tan square x terms, as sec square x minus 1. So we further simplify the term and we get sec square x tan square x minus tan square x. So now the integration has become pretty easy. Also, the tan square x can again be written as sec square x plus minus 1. So we get our final integration, or the integrand, as shown here. Now this integration is pretty easy. Let me show something for this one. We already know that the integration of sec square x is 10x. This one is standard, so this part is solved. How do we approach this question, this part of the integration? The idea to approach this part of integration is that we can see that sec square x is the exact differential of 10x. So we can substitute 10x is equal to t, and then we can proceed further. So let us see what they have done. They have solved the right hand side part, that is minus 10x plus x, and we are left with only this part. That is pretty easy. Now moving to the next slide. Okay, so now they have assumed 10x is equal to t, and now when we differentiate it on the both sides with respect to x, we get sec square x dx is equal to dt. So which implies that sec square x dx can be written as dt, and the remaining part, that is tan square x, we assume tan x is equal to t, so tan square x can be written as t square. And now this integration is pretty straightforward. That is the integration of t square is t cube by 3 or tan cube x by 3. So the final integration is tan cube x by 3 minus tan x plus c, where c is an arbitrary constant. So that is it. I hope you all got it. Thank you. Have a nice day.